All right, so ladies and gentlemen, here's your table of contents. Again, check your homework. The answers are posted that chapter 2 on Google Classroom. Second off, after we finish this video, please start working on the chapter review, which is your homework. So please finish anything you don't finish for your homework. Please do the constructions first in class because you won't have a compass necessarily at home. So please do the construction. Actually, there's just one construction. Do that first in class, and then you can do the rest at home if you need to. All right, so first off, let's finish where we left off in class. So please turn to page 14. Don't do this yet. We'll do this on Thursday before the test. We have 45 minutes beforehand. Please do the back of page 14 right here. Let's practice making sure we can find this here. So find the biggest circle fit inside. That's the in center. 3 angle bisectors. So we finished by doing 1. Let's go ahead and do all 3. If you're pressed for time, you could suppose just do 2, but let's try and see if we need all 3. So again, you put your point on C, you make a swoop, you see where those intersect here. You go ahead and put your point on those 2 and swoop towards the middle, swoop towards the middle, and you look for that intersection. Okay, that will be your angle bisector. So go ahead and draw that one in. Okay. And then let's do one more. So A, you're going to do a swoop, make it a little bit smaller here. Okay, put on here, make a swoop, point on here, make a swoop. So mine's just intersecting right there. So again, this is an angle bisector, angle bisector, angle bisector. So again, I've got a little bit of a gap here. It should be all one dot. But this is your in center. This is your in center, right, where the 3 angle bisectors cross. And so to test it, again, this is kind of involve a little bit of eyeballing. See if you can, turn it so this is kind of horizontal to you, and draw a perfectly perpendicular line. This is going to represent that radius there. So from here, go straight down, right? Because again, the in center is equidistant to the sides. I'm going to open up my compass to be that distance. Put the point on the in center, and I'm going to rotate it around and see if it comes close to just barely clipping all 3 sides. So just barely clipping all 3 sides. So mine went a little bit out. But again, you can see that this distance should be equal to this distance here. It should be equal to this distance here. All right. So on the test, you don't actually have to draw the circle, but I think it helps just to remember it. Second, for this guy, A, B, and C live at the vertices A, B, and C. They're planning to meet for a picnic. Where are they going to meet? See if you can do this problem on your own. Pause the video. See if you can do this problem on your own. See if you can figure out what center am I looking for? How do I do that? When you're ready, unpause and check your answer. Okay, so where are we going? We want to find somewhere that is equal distance, right? Equal distance to all of their houses, right? Equidistant to A, B, and C's. In other words, I want it equidistant to the vertices. Which one is equidistant to the vertices? That is the circumcenter. Okay, how do I find the circumcenter? Is it 3 angle bisectors, 3 perpendicular bisectors, 3 medians, 3 altitudes? Again, that is 3 perpendicular bisectors. So let's go ahead and draw 3 perpendicular bisectors and see if we can get them to all intersect at which one of these towns here. So again, for perpendicular bisector, let's draw for perpendicular bisector for AC. You open up your compass to be more than halfway. It doesn't matter how much more, just more than halfway. You put it on A, for example, and you do like a half 180-degree arc here, and then put your compass on C and do the same thing. Okay? And these two intersections, that's where your perpendicular bisector is going to be. Go ahead and put a box, tick, tick. It's perpendicular bisector. And we can do the same thing for BC. Okay, I'm going to shrink it just a little bit here. Okay, and where those intersections are, that is your perpendicular bisector. Okay. Box, tick, 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 tick. And it looks like we've already figured out that it's going to be this guy right here, E. But if you want to do AB as well, let's see, more than halfway. Okay. These intersections right here. Box, tick, 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 tick. Okay, so we can see the circumcenter is at right here, point E. Point E. So now to test that again, the circumcenter should be equidistant to the vertices. So if you want to put your compass here on the circumcenter and open it up to one of these vertexes, you should be able to go around the outside. So again, barely just clipping each one of these guys as you rotate. So we can see, again, this distance here, because it's the radius from here to this vertex, equidistant to the vertices. This distance is equal to this distance, which is equal to this distance right here. It's all just the radius of the circumscribed circle. Okay, so that was that. Let's go ahead then. So for the rest of the period, go ahead and take out this chapter review 1. This is page 16. Okay. And so finish what you can here. The answers will be posted. Please work on your own. If you could, please do number 10 first. So see if you can draw the 3 lines necessary to find the circumcenter. Put a big dot where the circumcenter is. This is your homework.